Last problem, problem number 7. Problem number 7 has to do with this. There is this air conditioner, okay, let us say that is over here, which is hinged or supported by a rod like this to the wall. Okay. Let us say we have something like this. So, it is the air conditioner is sitting on this and it is supported by this rod in the other direction. Okay. This is an air conditioner. The question that is asked is, let us say this angle, so I am just going to make it a little more better here. This angle, let us say, is theta. The question that is asked is, what is the angle theta for which cost of the rod is minimum? This is a natural question to ask, right, because I do not want to have a very long rod if this rod is going to be expensive. Again, very simple, we resort to equilibrium here. First we draw the diagram that is representative of the equilibrium equation that we have to write. In this particular case, we can take this air conditioner, okay, there is one support over here, another support over here like this due to this rod. The reason why I have drawn like this is there is one pin here, another pin here, assuming this is almost massless, the direction of the force on this rod has to be along these 2 points. Okay. We have done this exercise in the class and therefore, this is 1, this direction is theta. Let us call this as R of rod, RR. Okay. This is some reaction at, let us say this is A. So, we will call it as AY. It will also have weight over here, which is W. Let us say this length is L. Okay. The question is theta for which the cost of the rod is minimum. Okay. Now, let us first write the equation of equilibrium. Okay. The equation of equilibrium concerns writing an equation that relates W with RR. Okay. So, W with RR, if I take moment about this particular point, so I will take moment about A, summation of all moments about A equals 0 will give me W times L by 2 minus RR. Okay, I will just remove this subscript for now without loss of any generality, times cos theta L is equal to 0. All right. So, this will give me R cos theta, let us say L is equal to W L by 2, correct. What do I know about this length L and this theta? What is asked is I can have this theta varying. I can have something like this, I can have something like this, tell me which is the best, right, or in other words this theta could be varying. What would be the constant ones values? This L, the length between this is not changing, okay, the weight is not changing. If you notice here WL by 2 will not change at all. So, I can take this to be a constant. Okay. There is this reaction R and there is this cos theta, which are the two values which may change if I change theta, right. Let us look at the rod alone. I want to conserve on this rod. Okay. The cost of it could be proportional to the volume of this rod, and volume of the rod will be nothing but the length of the rod. So, let me just take it as L times the area, right. What is L here? L is this length, this is theta, this is a constant. So, I can write L to be capital L by sin theta, is it not? L sin theta is equal to this L, and so therefore, this volume is, and therefore, given this is equal to L A by sin theta, right. Now, let us go back to this and ask this question. I have something like this. Can I now write down in a fashion that I remove this length L? Okay. The answer is yes. If I do that, I will get this to be equal to A times this constant. Let us say this constant is some C. So, A C divided by R sin theta cos theta, right, or in other words this is equal to sin theta cos theta now can be written as sin 2 theta by 2, and therefore, I will get it to be 2 times A times C divided by R sin 2 theta. Please, this has nothing to do with air conditioner AC, though we are solving a problem of air conditioner. Okay. Now, I want to minimize this, which means what? I have to have a value of this to be the smallest possible. Theta, when it goes to 0, this will be maximum. When theta, I mean sorry 2 theta goes to 90 degrees, I will get the minimum possible value, or in other words, if 2 theta equal to 90 degrees, volume is minimum. This implies that theta is equal to 45 degrees, for which I can conserve the cost of this particular rod. Is this clear? Thanks.